Okay, Assalamualaikum and good day everyone. So now we will learn about isomerism. What is isomerism? Isomerism is the existence of different compounds with the same molecular formula. So, this stereoisomerism can be divided into two, which is the structural or the constitutional isomers and also stereoisomers. So constitutional isomers are the isomers that have the same molecular formula, the structure have the same molecular formula, but different in the order of attachment of atoms. How the atoms are bonded to another atom, to each other. Okay, so that is the structural isomer. And we look at the stereoisomer is the isomers with the same molecular formula, okay, but a different arrangement of atoms in space. Okay, so same molecular formula, but different arrangement of atoms in space. Okay, so the structural formula, the structural isomerism can be divided into three types. The first one is the chain isomerism, positional isomerism, and functional group isomerism. Okay. Uh, Meanwhile, for stereoisomerism, it is divided into two, which is diastereomer and enantiomer. Okay, so diastereomer is divided into another two parts, which is cis-trans isomerism and other diastereomers. Okay, so in your syllabus, we will only learn about the constitutional isomers. Okay, all of these. And also for the stereoisomers, you will learn about cis-trans isomerism and enantiomer only. So these are what we have in the syllabus. So the constitutional isomer is the isomer that is result. Okay, is when we talk about isomerism or constitutional isomerism is how we draw the structure, okay, different arrangement of atom, okay, or different attachment of atoms in the molecule. So since it can be divided into three, the first one is the chain or skeletal isomers. Okay, so chain isomer. So chain isomer will differ. Okay, as we label it as chain isomer, it will differ in the carbon skeleton. Okay, so different in the carbon chain, and it will possess. Okay, so the isomers will have the same functional group, and it belongs to the same homologous series. Okay, so what about positional isomers? So positional isomers is the isomers, okay, two or more atoms that have two or more molecules that have the same carbon skeleton and the same homologous series or the same functional group. Okay, and but the position of the homologous series or the functional group are different. Okay, so we can say it different in the position of the functional group or different position of the branch. Okay, branch or substituent. So if the structure don't have any functional group, so we will refer to the position of the branch, okay, of the uh, substituent. Okay, next is the functional group isomers. So functional group isomers will have different functional groups. Okay, different functional group means a different homologous series. Okay, so this is the functional group isomers. Okay, so this is the example of structure A and structure B. So structure A and structure B, when we check the structure, we will notice that structure A and structure B, both of it consists of 4 carbon atoms and 8 hydrogen atoms, but different attachment of the atom. Okay, how the atom are bonded to each other. Okay, so from here we can check that the uh, structure have both of the structure have the different carbon chain. So structure A consists of 4 carbon chain and structure B consists of 3 uh, three carbon chain and one substituent, one branch or one substituent. So this show that structure A and structure B have different, skeletal atau or the carbon chain. Okay, but it has the same, both have the same functional group. So it can be classified as the chain isomers. Okay, chain isomers. Okay, so next we move to stereoisomers. Okay, stereoisomers is the compound which have their atoms are connected in the same order but differ in the arrangement in space. Okay, for example, we have these two structure. Okay, two structure is the mirror image structure. So you will notice that, here we have hydrogen atom. Okay, for the first, the carbon at the left side, I label it as A, and the right side as molecule B. Okay, we check, for the hydrogen atom at the left side, and the hydrogen atom for the molecule, for B molecule B, at the right side. So this this hydrogen atom is mirror image, structure A and structure B is a mirror image structure. So mirror image structure. So each of the atom or group of atom are mirror image. Okay, so structure A at the left side will have uh, the mirror image structure, as structure B. Okay, so this is what we call as enantiomer. Okay, the other stereoisomers is the cis-trans isomers that consist of carbon-carbon double bond uh, or carbon single bond. Okay, carbon-carbon double bond in alkene and carbon single bond in cycloalkane. Okay, for cis-trans isomers, so these are the requirement, the requirement for the cis-trans isomers. Okay, the first one is the carbon-carbon, we have the restricted rotation. Okay, so this is the restricted rotation. Okay, about the carbon-carbon double bond in alkene or carbon single bond in cyclic structure. So now we look at, the figure that is shown here is for alkene, restricted rotation. It means that the carbon atom, you cannot twist, or you cannot rotate, the carbon atom. Okay, that is the first requirement. Okay, then the restricted carbon contains two different group. Okay, two different group of atoms or atoms. Okay, for the example, we have the trans isomer. Okay, here trans isomer. This restricted carbon consists of, each of the restricted carbon consists of two different group of atom. Means that you need to refer, okay, to this side and another side, and then you need to check whether the restricted carbon consists of two different group of atom. Okay, so it same goes to the structure. Okay, if the hydrogen is at opposite side, so at hydrogen or any other atom, okay, that is similar for both of the restricted carbon. So we can say that, okay, it is in opposite side. This is a trans isomer. So hydrogen, so opposite side. So this one will shows the trans isomer. Okay, trans isomer. Okay, but if the hydrogen or the atom is at the same position, okay, same position, so it is called as cis-isomer. Okay, trans and cis-isomer must exist together. Okay, you cannot say that you have the structure contains, okay, or has only trans isomer, but does not have does not have, okay, the cis isomer. Okay, so if the structure shows the cis-trans isomerism, you should be able to draw both the trans and also the cis isomer. Okay, also in the cyclic compound, we also have the cis-trans isomers. Okay, we check the position of the we check the first requirement is the restricted rotation about the carbon single bond in the cyclic structure. So hexagon is a cyclic structure. Okay, then each of the restricted carbon contains of two different group of atom. Okay, two different group of atom. So in this case, we check for the hydrogen atom, okay, which its position is at the opposite side. Okay, therefore it is called as trans isomers. Okay, and cis isomers is when the hydrogen or the similar atom is at the same side. Okay, so we have the cis-trans isomerism at in alkene and also in cyclic compound. Okay, so this is the example of cis-trans isomers. Okay, check. Okay, so when you want to check for the existence of cis-trans isomer, you need to remember that there are two requirements. Okay, first is the restricted carbon about carbon-carbon double bond, or the restricted carbon about the carbon single bond in cycloalkanes, and the restricted carbon contains of two different group of atom. Okay, for the example, we have the structure of structure A. We can say it. I label it as structure A, and we we said that since the hydrogen atom, okay, the position of hydrogen atom is at the opposite side. Okay, therefore this is the trans isomer. Okay, trans isomer. Right. So cis isomer will shows the hydrogen at the same site. Okay. So the physical and chemical properties of cis-trans isomer. So cis-trans isomers have the similar chemical properties but different physical properties. So what are the physical properties that you should know? The first one is the melting, okay, melting point. Okay, and then the boiling point and the solubility. Okay, solubility that is different to the uh, polarity of the molecule. Okay, we can say that the trans isomers will have higher melting point because the molecules are more closely packed in its solid lattice. So melting must refer to a solid, okay, the structure of solid. Okay, uh, for boiling point, okay, we refer to the boiling point of liquid. Okay, boiling point of liquid. How we want to overcome the intermolecular forces that exist between the liquid particles. Okay, so in liquid particles, we said that the cis isomers, it is a polar molecule. So it shows the dipole forces or stronger van der Waals forces. Okay, van der Waals forces. So dipole forces is stronger than London forces. So when dipole forces is stronger than London forces, therefore more energy is needed to overcome the intermolecular forces. Okay, thus the boiling point of cis isomer is higher than trans isomer. Okay, so these two physical properties you need to remember. Okay, and what are the factors? Okay, okay, the factors is you need to check for the van der Waals forces or the intermolecular forces. Okay, between the particles, between particles. Okay, whether London forces or whether dipole forces exist, okay, between particles. Okay, for melting, okay, melting, okay, also for melting, you need to check the stability, okay, the stability of the solid, okay, the solid lattice. Okay, so make sure that you discuss further in tutorial. Okay, so we have next the enantiomers. Okay, for the enantiomers, we have the chirality center. So chirality center is the sp3 hybridized carbon atom, which is bonded to 4 different atoms or group of atoms. Okay, so chirality center can only exist for carbon atom. Only carbon atom is discussed for the chirality center, and it must be the carbon atom which is a single bond. Okay, sp3 hybridized carbon means that carbon single bond, and is also known as chiral carbon or asymmetric center or stereogenic center, and usually it is labeled as asterisk lah. Okay, so usually when you want to show the existence of the chirality center, you will mark it with asterisk. Okay, so this is the 2D structure, okay, of a chirality center with for a molecule with a chirality center. So we have a carbon here. All of the carbon atom is a single bond. Okay, center, carbon at the center is a single bonded, okay, is single bonded to another 4 atoms, okay, or group of atoms. Okay, so usually for you want to check, okay, the stereogenic center, just label it with asterisk, okay. But if you want to draw the enantiomer, you must draw in a 3-dimensional structure. So what is enantiomer? So enantiomer is a pair of stereoisomers, okay, that are mirror image to one another, to each other, and not superimposable. So means that it cannot tidak boleh bertindih tepat lah. Okay, you cuba untuk overlapkan dia, you nak imposekan dia tetapi tidak boleh bertindih tepat. So that is the characteristic of the enantiomers. Okay, so it contains the chiral carbon, and when you draw in 3-dimensional structure, so you will have the dash, okay, here is the dash, okay, dash, wedge, okay, yang tebal ini adalah wedge, okay, and then we have the atom that lies on the plane, okay, lagi dua tu akan duduk atas plane. Okay, so we usually draw a mirror, okay, mirror to show the a pair of mirror image molecule lah, which is the stereoisomers. Okay, so this, okay, when we have the COOH here is, okay, that lies on the plane, so the mirror image also must shows the COOH, the image also mesti ada dia punya COOH that also lies on the plane. Okay, same goes to other atoms or other group of atom for CH3, hydrogen and hydroxyl group. Okay, so this is the plane of symmetry. Okay, for 3-dimensional structure. So you imagine your plane. Okay, plane here. So this plane, okay, this plane is usually represented. Okay, is represented by line. Okay, solid line. Okay, solid line. This hydrogen and chlorine which lies on the plane, okay, dia berada di atas satah, pada satah, maka kita akan lukis garis yang solid lah, solid line, okay, solid line. Then the wedge, okay, is the atom or group of atom that coming out of the plane. So berada di hadapan lah. So jadi pandangan mata kamu kat sini. So jadi pandangan mata kat sini, jadi kita akan nampak lah yang ini fluorine atom ini berada di hadapan. Okay, and hydroxyl atom. So hydroxyl atom or OH group ini at the back of the plane, okay, ataupun behind the plane, okay, the symmetry of the plane of symmetry, okay, plane of symmetry. Therefore, you akan lukis dengan dash lah, okay, dash, okay, dash ini, okay. So I think that's all for isomerism and stereoisomers. So I hope that you can answer the question regarding stereoisomerism and continue. You can continue discuss any problems or doubts in your tutorial class. Okay, with that, I'll see you in the next class. Okay, thank you.